We're talking through the Snake Pit X puzzle by Joseph Howard called series. You can see these increasing digits on different parts of the grid, but we've got 4 series of clues, and the big digits will probably crowd each other out, but let's start with some of the small ones, as 2 can't come up and join to that X, so the X is a quick place for that 3 to be placed. Not seeing any other forcings around that 2. We're going to have a connection into the 4 or 5 from here, but that's about as much as I see there. A little bit of apparent attention in this lower right corner, so the 5 can sort of skirt around, which lets the 6 get out this way, but if the 5 ever comes up here, the 6 is going to have to come to the left, which is going to move the 7 up. So we're going to start to think through that a bit. One thing, maybe these X's on the edges are helpful, and this is a good one. It's near 2 digits, so we know that we've got to choose 2 of these 3 ends. What we can't do is choose left and up together and not take that end. So for sure this X comes down. That's going to close off the snake this way. And then I think the thing to think through is what happens if this doesn't join to the 4. This 4 is now effectively isolated. It can come to this snake end to the left, but then it can only be 3 units. And if it dodges that snake end, it comes to an unusable cell here. So looks like the first place to get some break in is to mark this in, and that 4 snake still has 2 options. It can come left or up, so not more to do with that. But it now actually means this 5 has to come left, means this 6 has to come down. So we're getting some crowding, and then it also has to come left to have enough room to grow. This 7, does this 7 work if it doesn't come down? Let's see, if it came even to here, like it can take 6 cells to here. So it looks like this position has to be part of that 7 somehow. And if that's part of the 7, then the 6 can't actually come up here and go farther than like this cell. Actually, that's not possible. The 5 actually needs to take all these. So the 6 can go only as far as here, so 3 cells, so it has to come to this. That means the 7 has to come up, and the 7 is not going to be able to come through this channel. It should close off this 6 too quickly, so it's got to come over here. So it actually joins to that 7 we marked as an intermediate point of knowledge. This 7 will have to join to this 7, and it's got 2 cells can work, but it can't take 4 cells, so this has to come straight. So we got this shape. This comes over one more, this comes over one more. Let's see if we've got more that we can deduce from that. So here's an X. It has to not be an end of the snake, so it's got to come up and down. That puts in these cells. In doing that, now this 5 doesn't have a lot of room to grow. This 5 can't reach to the cell because it now can only take 4 if it does that. So it has to come up this channel instead. That takes this end. It isolates this cell, which means there's a 2-unit snake and this 5-unit snake this way. The 6 now has to effectively corner. Has 2 options, this cell or this cell. This is a 3-unit snake right now. If it grew to be a 4-unit snake, it would touch a 4-unit snake, so this closes. That means we now know the last cell for the 7 clue. We can mark this off. We have more than that. Not that I see right now. It may help just to get more visual space to put in some of these numbers and see some of the boundaries, because what we'll see in doing that is now this 8 has pretty firm boundaries. It's got to come left and down. It's not going to be able to grow large enough without doing that. That's now limiting this 9. This 9, you can join over to this potentially. Either the 8 or the 9 can do, like these 3 cells could be a 4th cell, 5th cell, but this will be a 1st, 6th, 7th, and 8th. It's going to have to come through this channel. That means the 5 is going to have to come up. This 4 is going to have to come left. This 3 is going to have to come left. There's still, though, not a lot of space here. So one thing I'm curious about is how does this 8 work? How does this 9 work? Well, the 9 can, if it's taking all this stuff to the right, sort of pack all the way into here and have a lot of options for the 5. So it looks good for the 9 to come over here. So I think one question I have then is, can the 8 work if it's stopped right immediately? And this is where a thing we can do with these snakes, if this is the end of the snake, is effectively know what kinds of cells can be the other end of the snake. It's going to have to be in parity with it. So this is an even cell, even cell, even cell, even cell. So this could be an end, this could be an end, this could be an end, but it's an X. This could be an end, but it's already there. This could be an end already there. So it looks like this cell and this cell could be the ends. For this to be the end for that 8, it can't come quickly to this. That would be a 6-cell path. Again, we're assuming this edge is in the grid. So it's going to have to be a long path like this, and doing that, the 6 comes up, and it's going to leave behind a singleton, so that doesn't look any good. And if this is the end of the 8, notice what it's doing is it's leaving behind 3 cells with a 2 in it, so both of those look very bad. So I think there's enough crowding in this grid that the 8 can't work on its own in the bottom without taking the cell. And that now helps us know this 9 needs to take even more than we've given it. It's got to come further to the left. This now is only taking 6 cells, or this is going to be an end of it. It needs to take 7, 8, 9, or 7, 8, 9. So these are part of a 9. How does this 5 work then? Well, it can take these cells up, but that's not going to work out unless it reaches all the way over to here. So we actually have this path to mark enough of these. It can take 1 on this side, but always have to take this on this side. This end is going to have to live on its own, and that means this 5 is a U shape. This completes the 2. The 9 completes this way. 4 is coming down. Where can this 4 end? The ending cells can be this cell, or this cell, but this is already an end of the grid, so no good. If it comes to here, like how is this 8 going to work? Let's think about that. This 8 could take these two, and these two to get to 6, but the 8 looks like the 8 itself also now still has to end in a cell like this. So the 4 can come to this cell, provided the 8 has an ending, which can be this cell right here, and that's going to require to take these. It can't come down and left, it has to come left and down, so it doesn't leave behind a single corner. This 2 is going to come down here. This is an end for a snake, so these have to come across, fill in this 3. 6 comes there, and got 2 cells left. So it looks like we've got the bottom of the grid pretty well set. Marking the cell for the 9 gave us some more logic around the 6. We can't take this cell because that would just be 5. We have to take this cell for 5, joining to this extra 6 to complete 6. That means this 5 comes here. Where can this 5 end? It can't end at this cell. It could end at this cell. It can't end here, or it could end here. So let's think about ending at this cell, because I don't think I get enough from thinking this way. Like, there's still a lot of options. I think the conclusions will be easier if I'm like taking this path, which is cramping the space, because what it's effectively doing is putting this into the grid, which is 8 cells here, one of them with a group of 4, and the other is going to become another group of 4. So this or this are both invalid packings of that. So we can't reach out with this 5 up to the top. We have to come efficiently over to make this U. That U strands an X in a corner, so this has to be part of the shape. This 5, we're, again, like all of this thing is going to be about stranding groups in different ways. If this 5 doesn't come up, so we take these edges, then this 5 has to come over 1, and it only has 4 cells to take. So this X always has to take this cell down. That means this end has to come up. It means that this 5 has to take this U. Forms this 5, this 3, and this 4. Still, a lot to kind of do in this corner, so let's remove what wasn't true progress. But let's think again, like these X's have 3 options. So let's think about a counterfactual where we consider if we took 2 of them, what would happen? And so let's say we don't take this. We always had to take this corner, and we make this S shape. That's a 4. It's near a 4. That 4 actually also leaves behind a 1. So one thing I know is I take this edge. Can I do something like that now above? This X can't take these edges together anymore because of this edge we know down here, so I have to take this edge. Can this come down? If this comes down, this then has an issue where these ends don't work, so this is an edge. This is an edge, we know for sure. Let's see, it's probably going to be looking around the 2 options for this 4. If this comes up, then this forms a 3, this forms a 3, those don't work, so this has to extend, this forms a 6, it now touches a 6. So this is a long but provable path that's going to exclude enough from the grid, so 4 doesn't come up, 4 comes to the left. That means this comes over here. If this ended at this circle, it'd be another 4, so that doesn't work, so it comes down, but now it's a 5, can't end as a 5, so it comes to here. And we're left with 4 cells, which have to be an intact 4, not a 2 plus 2. So pretty good workout through this grid. A lot of crowding as key constraints. I think seeing how this X on the corner got you started, thinking through the 5 coming down, the 6 coming down, the 7 working around, getting these 8s and 9s together. Seeing the intense crowding of the 8 in the bottom of the grid, including that it couldn't end in this cell or this cell, so I was forced to take this edge, was a key intermediate aha. and then working through the rest was an effective form of counting and some look-aheads, particularly like this upper right corner was still super tough despite all the intuition we used elsewhere in the grid. So thanks, Joseph, for this really challenging puzzle. It stretched our snake pit skills to their limits, and hopefully you as viewers got something from watching this video and seeing how I approach this puzzle. So thanks for watching, and we'll see you again soon.